Hi families, Mr. Cotter here. As you'll know from reading our weekly update, we're working right now in mathematics on adding and subtracting numbers. In grade 3, the expectation is that we work with numbers up to 3 digits so that their sums can be up into the thousands. So I've had some questions from some families about what math looks like, particularly with numeracy, compared to the way that math might have looked when we were growing up. So I thought I'd share some of that with you today. So this is a problem that we were working on today together in class. So you'll see that the kids actually had to come up with their own numbers in these spaces. And then they had to estimate the solution and solve the problem and explain their thinking. So we did this together on our tables with whiteboards. And then we were really looking at the different strategies that we were using. So you'll notice that they have to figure out how many boxes are in the warehouse, how many more boxes were brought in, and then how many boxes were taken out and how many boxes are left in the warehouse after all of this happened. So there's adding and subtracting both happening within this problem. So we try to work on it at the same time to see that they're really just opposite processes. So I'm going to show you how we do that and some of the materials that we use. So let's say that I was working with that particular problem and I was saying that I had, if I'm doing a 3-digit number, let's say that I had 185 boxes in the warehouse. And then when I'm saying that there are boxes being brought in, maybe I'm bringing in 246. Now, one of the tools that we use quite frequently is base 10 blocks, and we've set up these great little kits in class that kids can access whenever they need. So with base 10 blocks, the nice thing is it really shows how you've got your ones, you've got sets of 10, you've got your hundreds, and then as we're getting into the bigger numbers, we even have these big guys, which of course is our 1,000. So it really shows the relationship between those numbers. So first thing I would do when I'm working with kids, if we're going to be adding two numbers together, is we want to actually represent the numbers. So we're going to be showing 185. So I'm thinking, well, I've got 5 ones. I'm going to put those aside for the moment. I've got 8 sets of 10. Okay, and then I've also got 100. So I'm going to set those aside at the moment. You'll see them in just a second. And then I also want to get my 246. I could always go backwards through this. I could do my hundreds first. So I've got 2 sets of 100. I can get my 4 sets of 10. And I can get my 6 ones that I'm going to need. And I'm just going to put my kit away for now. I don't need it too much longer. So now I'm able to actually go ahead and do the math. Now, sometimes kids will look at this and they will say, okay, well, I'm going to add my hundreds first. So I know it's going to be 300 something. But then as they start to look at it, they realize that I actually have enough tens that I'm going to be able to make another 100. So I think I'm actually going to have 400 something. And that's great because that's part of the estimation that we work on. But let's say that we were doing our standard algorithm, which is what we grew up with. So of course, we're going to set it up as we usually would from when we were younger. And then, of course, we start with our ones when we're doing the standard algorithm. As I said, with mental math, you don't have to, but with the standard algorithm, we do want to start with the ones, just like we always have. So we start with those ones, and we're really seeing here that if I've got a set of 5 and a set of 6, of course, the kids understand pretty quickly that, well, 5 and 5 makes the 10, and then I still got an extra 1 there. So here's the really important part and where it changes a little bit from where we were growing up. We used to talk about carrying a 1. We don't really do that anymore because what we're understanding now is that this here actually makes a new set of 10. So instead of actually saying I'm going to carry a 1, I'm realizing that I am creating a new set of 10. So what I'm going to do is I'm going to put, well, there's 1 that doesn't fit in a set, and I've made a new set of 10, okay? And I can even get rid of those 1s at this point because they're no longer 1s. They've become a set of 10. And now I'm looking at my sets of 10. So I know that I've got the new one that I've just made. I have the 8 from 80, and I have my 4 from 40. And that's where I'm starting to realize that, well, if I had my 8 from 80, one more makes 9, and then one more makes actually 10 tens, which is 100. So I actually have 13 sets of 10. So I'm going to say, well, 13 sets of 10 is 130. So there's my 30 in the tens place. But because I've actually been able to make a new set of 100, again, I'm going to trade those in. And now I've got a new set of 100 that I'm going to put up here. And then I'm just adding together all of my hundreds. And I'm going to realize I have 4. Okay, so there's my 431. If, of course, I had enough, then I could even, if I had more than 10 sets of 100, then I would actually be needing to trade in and getting up to my 1,000 block. So that's what it looks like for addition.